Okay, Assalamu alaikum to all attendees. We'll be starting our lecture shortly. Just a recall, we are into week number 15 of the semester, and this is our first lecture of the week number 15. So the good thing is that this is your last topic of the semester. It's relatively long, but we'll try complete it in say 3 to 4 hours, so that at the end we have some time for discussion, so that we can take your queries and we can have some general discussion, right? So from the viewpoint of content, this is your last topic. So today what we'll do, as I shortly a little while back I posted on your web page, today we have a 2 hour session, but we'll do a 1 hour session, right? At 11:10 you have a quiz. That is all MCQs, nothing else. Okay. That is again a bonus quiz. So if anyone wants to improve their score, they are welcome, right? If you don't want, there's no need to attempt the quiz, right? It's just to compensate any missed quizzes or any quizzes in which you could not score well, right? So it's an optional one. We'll be starting it at 11:10, right? But the important thing is that today we'll be having only 1 hour, and for the missed hour, I'll coordinate with your CR, and then we can have a makeup, right? So let's get started with the technical part. So today we'll be talking about files and streams, right? And it would be a bit different from what you have been looking at in the previous weeks. Okay. So first, let's discuss what is a stream. So I'm sure you must have heard of this term in the real world as well. Stream, normally if we talk in daily life, stream refers to flow of water, right? That water is flowing. But when we are talking in terms of programming, then sorry, still we are talking about flow, but this is flow of bytes, right? Flow of data. Your bytes are moving from one place to another. For example, when you type something on the keyboard, right? So there's a sequence of bytes which is moving from input device to your program. Similarly, when you write C out some message in a program, so that message is flowing from your program, which is in memory, to the output device, right? So that flow of bytes is called streams. So let's discuss it in a bit of detail, right? Let me just open this board, and then we discuss. Okay. So you see, normally you write a program. So this is your program, right? We say this is our C++ program. So in your program, you have many variables, right? And these variables get value from some external source. Okay. For example, when you do a cin, you have a keyboard. Okay. So you type something and that value goes into some variable. Say suppose you write scene X. So whatever you type, that goes from this input device to that variable in the memory, right? Similarly, keyboard is not the only way to accept input, right? You can have data in some text file .txt, okay, where some data is written, and you can read that data in a string. So again, whole of this text, which is a sequence of characters, will flow from disk in a text file to a variable in your program, right? And similarly, of course, you can also read data from other sources. So when your program is getting data from somewhere, this is called input stream. Why we are using the term input? Because with reference to our program, we are getting something, right? We are inputting something in our variables which are in the program. So most in most cases you are familiar with keyboard, but as I told you, there are many other sources from which you can get data. So to generalize them, whenever your program is getting data from somewhere, we'll refer to it as input, right? Similarly, you know that you can display your data, right? For example, this is your display console. So you can write C out some variable. So your variable will go from memory to this device. You can also send your data to a printer, right? That is also possible. Maybe we have not done it, but in some advanced courses you will see that how you can write a code which can send your data to the printer rather than to the display. Okay, that is also possible. And similarly, you can write your data in some file. You can store it on the disk. right? That is also possible. And of course, there are other possibilities as well, right? So whenever data is flowing from your program to some device or some file, this is called output stream. Okay, because our point of reference is our program. When we are getting something from somewhere, it is called input, and we use the terminology input stream. And when we are sending some data either to the display or the printer or to file, we are outputting something. Our program is outputting something, so that's why we call it output stream. Okay, so now let's see for this one. You have already seen that if you have to get data from keyboard, you are using maybe cin. Okay, so cin helps you achieve this. If you have to do this, you have this cout, right? So cout actually helps you to send data to a you can say display device, right? But the focus of our discussion would be this part, that what we'll do if we have to read data either from a text file or we have to write data to a text file, right? So this is something new that we'll see, and that would make the topic of our discussion today, right? So let me go back to the slides and let's continue our discussion. Okay, so this is what I was telling you, that when your program is getting data from some source, it's called input stream, right? Source can be like a keyboard, text file, or some other program as well, right? It is possible that maybe this is program in Java and it is you are reading something, a C plus program is reading data from program in Java, right? Similarly, when you are giving some output, right, some variables which you can pass either to the display or to another file or to another program, then this is what we call output stream. Now, as we discussed that we are already familiar with cin and cout. What are these? We'll also discuss, right? We have been using it like for 2 semesters now, right? But today we'll see a bit in detail what is actually cin, right? So, but anyways, you are familiar with them, right? But when you have to read data from a file, right, you will use something which is called if stream. What is this if stream? I stands for input, right? So I is actually input. F is actually for file, and stream we have already discussed what is stream. Okay, you are already familiar with IO stream, which is input output stream. Okay, so it is very much similar, but if you want to remember their name, when we say if stream means input file stream. So when you have to read data, you will be dealing with input file stream. Off stream means output file stream. So when you have to write data in a file, you have to save data somewhere, we'll be dealing with output file stream. Okay, so whenever we are talking about stream, okay, input stream or output stream, you should look at them like a communication channel, right? For example, when we are reading data from the keyboard, so this is your device, this is your program, so there is a communication channel through which data is flowing and it is going in some variable which is in your program, right? So when you write cnx, so actually data is here, data is being provided through keyboard, and there is a communication channel which will take that to this variable x in the memory. And similarly, when we are talking about the output stream, then there is again a communication channel which is from your program to the console or a network or anything where you are sending your data, right? Okay, now let's just let me just show you a diagram and then we discuss further. Okay, so this is an important diagram that I'm not sure if you have seen it earlier or not, but somehow you have been using these, right? Now what is this? Every box is a class. Okay, so you can say it is a simplified form of a class diagram. And what are these arrows? If you remember, arrows are used to represent inheritance in a class diagram, right? So an arrow is pointing from child class to the parent class. So it means these are classes and some inheritance has been done. And these classes, we have not developed them. They are already coming with C++ distribution, right? You don't need to memorize their name. There are only few of these which we need to talk. So you see at the very top, you see a class which is called IOS. It is like input output stream. It is like, you can say, the grandparent of all the classes which are related to reading data and writing data. Now now you can correlate it with what you already know. You see, there's a child class iStream and there's a child class OStream. So you see, whatever you see on the left side of this tree, this is all which is related to input, and whatever you see on this right side, you see, this is all which is related to output. So now you see, iStream is a class which you use for input, OStream is a class which you use for output. And do you see this IOStream? You see, it is a class which is using multiple inheritance. It means it has capabilities of input as well as output, because when we do inheritance, all the features of this class, they go to this child, and all the features of iStream, they also come here. It means that now this class IOStream, it has the capability to input data as well as output data, right? So this is what you have been using. Okay, now let's in the context of this, let's discuss cin and cout. What are cin and cout that we have been using for more than a year now? So you know, you are very much familiar with statements like, when you were writing your first program, maybe you did something like this. Okay, and similarly, when you want some data, so you do a. Now let's discuss in more detail what is this. So you see, when you are new to programming and you have to display data, anyone who is your instructor would ask you that if you have to display data, you use cout, and if you have to get input, you will use cin. It is very much okay, because at that stage we cannot tell you what these are, but now we are in a position to discuss in more detail what these are. So you see, this cout is some people think it's a function, it's a command, it's something. It's none of these. This cout is actually an object. Similarly, this cin is also an object. When there is an object, there has to be a class. So this cout is actually an object of class OStream. Okay, and this cin is an object of class iStream. Now let me go back and show you the diagram so that you can relate what I'm talking about. So you see iStream on the left, this one, where I have, so iStream, cin is an object of this class, and OStream, which I have mentioned with an arrow, cout is an object of this class. Okay, now let's go back. So when we say object, so then we say, okay, then what is this? So this is actually an operator which is overloaded for this class. Like, you have been doing operator overloading, you have been doing it with your own classes, but this is an operator which is already overloaded for you, because you see, displaying data and getting input are very common features. So instead that every developer has to do it from the scratch, they have already done it for you. Similarly, this is also an operator which is overloaded for this class. So now you see, when you write a plus b, this is operator, this is operand, this is operator. Now you compare cout with the same thing. Okay, we have, let me change the color so that it is more visible. You have, say, cout, this, and maybe x. So now on the left side you have an operand, on the right side you have an operand. Okay, so this is an object, this is some other data type, which in this case is an integer, and this is your operator. Okay, so and similarly you can replicate the same concept for cin as well, right? So after this discussion, you should be convinced that cout is an object of class OStream, cin is an object of class iStream. When we write cout and this uh, operator, so why this is a legal statement? Because this operator has already been overloaded for this class. And on the left side we have an object, on the right side we can have any basic data type, right? Like integer, float, character, string, or anything. And another important thing is that you might be thinking that when we write a program, we never create these objects, cout and cin, right? And the reason is that these objects are already created when you use include iostream, right? So these objects are already there. You can directly use them. You don't need to create them, right? But the important thing is that now you should be knowing that cin and cout are objects Scene is an object of iStream for inputting data. Cout is an object of OStream, right? And maybe tomorrow or in the next week, we'll come back to scene and cout, and we'll see how we can use scene and cout with objects of our own classes, right? I think a couple of weeks back, one of you asked how we can use cout with objects of our classes. So I requested them to hold on. So now is the time that maybe in the next session we'll be able to see how we can use cout and scene with objects of our own classes, right? But anyways, let's go back to our main discussion for today. So okay, so this we have already discussed that scene is an object of iStream class and cout is an object of OStream class, and operator overloading has been applied to all of the classes in this library. Okay, now now with this context, now we are in a position to discuss how we can read data and write data from files. Okay, means we will not be using scene and cout, because scene is used with for input from the keyboard. Cout takes your data to console. Suppose you have some data on file and you want to read data from a file. Okay, and so this is what we are going to see. So you see, all the programs that you have been making so far, you have variables, and variables are in the RAM. So as long as your program is running, right? For example, if you have a variable, say x, which is like 5, so as long as the program is running, you can use x, but once the program terminates, this is gone. Okay, means this is not stored anywhere, right? Similarly, maybe storing a single variable is not useful, but suppose you have a class student, right, and you want to store data of all the students. So you will have a class student, you will have an array, so every student will have some data, right? So this is the data of students, like student 1, student 2, and so on, right? S1, S2, S3. So you have entered data of 3 students, like their complete profile, name, address, GPA, phone number, everything, right? But you see, as soon as your program ends, all of this data is gone, right? So when you run the program again, you have to again enter this data. So you see, for short programs it is okay, but for most of the practical programs this is not very useful, right? Because if I have to enter data every time I run the program, it doesn't make sense, right? If I am storing, for example, if I make a small program to store the marks of quiz and assignments of all the students, so I will enter once, right? And I expect that when I run the program next time, whatever I have entered, it should be stored somewhere, right? So this is what we are trying to do, that rather than having values in the variables, we will store those values in files, and those files are stored on the disk. Means there is a file like, say, abc.txt, and all the data is here. If I enter some data, I close the program, I again run the program after 10 days, the data is still there, right? Because storage on the disk is permanent, it is not volatile. So this is what we'll be doing. But before that, we need to see how data is organized in file, right? So eventually everything that you enter is translated into bits, right? Either 1 or 0, right? So we enter something from the keyboard, maybe a string or a name, but eventually when it is stored, it is not stored in the form of characters, it is stored in the form of bits, right? And so the smallest unit that we can talk of when we are talking about computing is a bit, which can have a value 0 or 1. But you see, if you simply see a string of 0 and 1, so as a human you cannot read it, that what is this, you cannot interpret it, right? For computer it's okay, but for human we need some meaningful representation which we can understand, right? So that's why we have organized data in a hierarchy, right? The smallest unit is bit. You can group bits, right? For example, a sequence of 8 bits, you must be knowing from your basic knowledge of computer, is called 1 byte. And 1 byte, for example, can store a character. Similarly, if it's an integer, it will be 4 bytes, and so on, right? So then you can group characters, for example, to have a name, right? For example, there are some characters, and a sequence of character will make a name which is meaningful for you. Likewise, you can have first name, last name, address, phone number, and so on. You can group these together, and that is called a record. right? Which you can implement with a structure or a class, right? When you make a structure or a class, you have different fields, right? For example, when you made structure point, you had x and y, you have two fields, right? So when you group different fields, it is called a record. Can be implemented with a structure or class, or in some other programming language maybe it would be something else. And then when you have many structure, like you are entering data of many student, it is called a file, right? For example, you have one student, second student, third student, so all of these make a file. And when you have a multiple file, right, one for student, one for faculty, one for admin, then it is called a database, right? So if I show you this in a hierarchy in a visual form, maybe it will make more sense to you. So as we said, the smallest unit is a single bit. You can group bits together, and a group of bits can have something meaningful. It can be a character, it can be an integer, and so on, right? And then in this example, we are taking example of character because characters are relatively easier to understand. So for example, this is one character, which is J. If you have a sequence of characters, maybe they will make up a name which you understand, which is meaningful for you. And then when you are storing data for some individual, like first name, last name, and other fields, then this one, you can say, record, this one group of fields is called a record, right? And if you are storing data for many such students or individuals, then this is called a file, right? So this is how data is organized. But from the perspective of a computer program, computer is only dealing with this sequence of bits, right? But as a human, we deal with this because it makes sense to us. Okay, now when you are storing data, as I told you, it is simply stored as a sequence of bits, right? Sorry, 1 0 0 1 1 1 and so on. And when at the end of the file, there is an end of file marker, right? What is end of file marker? Basically, when you are reading data from a file, okay, and we don't know how much data is there, okay, so there must be some signal to the program that data has ended, right? So as we'll see later, when you are reading data from a file, your program is checking whether end of file has been reached or not. If end of file is reached, it means there is no more data to be read. Okay, so that your program will get a signal, and then you can use a loop so that you can terminate the loop and you can stop reading the data, right? But of course, we'll see it later. I'm just telling you the general concepts. Okay, so now let me go back to board and explain you some other related concepts, right? So as I told you that when you are reading or writing data previously, you have been using object of OStream, which was cout. Okay, so you have been using this already. Similarly, iStream class, there's a class iStream, and it has an object scene, and you have been using this already. Okay, so when you want to read data from keyboard, you use object of iStream. When you want to write data on the console, you use object of OStream, which is cout. Okay, now if we want to read and write data to files which are stored on the disk, okay, suppose this is some file. So for that, again, we need to create object of a class. Okay, and what are those classes? Let me write. It's very easy. Input file stream, this is for reading, right? You can relate these two together. This is a class. So if you want to make an object of this class, what you do? If you make an object of class point, we used to write name of the class point and p, or we can call a constructor which is a parameterized constructor. Similarly, this is your name of class, and you can write some object name like f, or it can be any name. It can be f in f1 f2, whatever you like, right? So I call it fi so that we know it is for input. Okay, so let me just make it more clear. This is your class, and this is your object, and you can relate it with how you create objects of classes. Okay, the only difference is that scene and cout are the objects which are already created for you. You don't need to create them. But when you are reading data from file or writing data to file, you need to create object. So for reading data from file, you create an object of class if stream, and if stream stands for input file stream. It is for input, it is for reading data, right? Let me write it so that it is clear. It is for reading data from file. And similarly, when you want to write data to a file, okay, you have some variable, you want to store them in a text file. So you will create an object of this class, which is called offstream. So again, this is for writing data to a file. Just like previous one, this offstream is your class and this is your object. Okay, so summary so far is, if I have to write data or save data in a file, I create an object of class offstream, which is short for output file stream. If I have to read data, I will create an object of if stream, which is short for input file stream. Okay, and there's a third class which will not be using very frequently, which is actually, you can guess from that diagram that there's a class which is called fstream. So fstream is actually derived from both if stream and off stream. So fstream can be used both for input and output. Okay, so if stream is for input, off stream is for output. But if you want, you also have a class available which is called f stream. Using an object of this class, you can read data, you can write data, means you can do both of the things using the same object. Okay, but I would recommend you that you should use if stream and off stream rather than f stream. Okay, so now let's discuss one of these in more detail. This was just more like an introduction. So let's start with this one. Okay, maybe we discuss off stream because first we'll write data and then we'll read it. Okay, so let me go into more details of this off stream. Okay, so you see, as I told you, when we are writing data to a file, you make an object of this class of stream. Let's call it f. Okay, so whenever you make an object of a class, constructor is called. You already know that. So in this case, default constructor has been called, right? But just like we do, this class also has a parameterized constructor. Okay, and what is that? Now you should think that, okay, when we are creating an object of a class and we want to write data to file, what should we tell our program? The most logical thing is we should tell the name of the file in which we want to store data. Okay, so either you can write like this, or you can also call the parameterized constructor of stream f, and here you can write name of the file in which you want to store data. Okay, so for example, I call it data.txt. So both of these are constructed. On the left side, you are not telling the name of the file, but on the right side, you are telling the name of the file. Now what will happen? Whenever you will use the object f to store data, that data will be stored in a file data.txt, right? And many students ask where this file is created, right? Because this file is not already existing. So this file is created in your current directory in which all of your source code and your project is present. Okay, and if you want some other location, so you can, instead of giving the name of the file, you can give the complete path. For example, c data, and within that you can write d.txt. Okay, so file name can be simple name or it can be a complete path. If you only give name of the file in which you want to store data, this file is created in your current directory where all of your source code is present. And if you want some other location, you can actually write the complete path. Okay, but anyways, let me just erase this so that we have some space for discussion. Okay, so if someone is not telling the name of the file here, okay, then of course, just like when we are making point class, we can set the value either in the constructor or we can call the set function, right? So we have the option. So similarly, if you don't want to tell the name of the file in the constructor, then of course later on you have a function which is called f dot open. Now you see how we are calling the function. F is object dot name of the function, and you can specify name of the file at a later stage as well. So both of these are actually doing the same thing, and to understand, you can compare it with classes that you already know. So I told you it is like you are saying point p 2 3 class, object, and parameterized constructor. Same is here, name of class, name of object, and arguments of the constructor. On the other hand, on the left side, we are doing something like this. We do not call the parameterized constructor, and maybe later you have a function which you can call to set the value of x and y, right? Here, of course, the name of the function is not set. The name of the function is open. Now, what will happen with this? Okay, so now this is your program. Okay, and you have given name of a file data.txt. If this file already exists, it's okay. If it does not exist, it will be created. Okay, so when you write these statements, if the file is already there, then it's okay, nothing needs to be done. But if this file does not exist, it will be created. Okay, and a channel will be established. Of course, this is hidden, you can't see it. There's a communication channel between your program and this file. Okay, so with these statement, what is happening, that we are creating a file. If it does not exist, if it exists, it's okay. And we are associating f, which is the name of our object, with this file. Okay, so now we are saying that f is associated with this file. Whenever we are using f and we are writing data, that data is going to this file, right? So this is what is happening with this constructor, or the constructor and the open function, right? So we have not written anything yet, right? But if there are some queries, then maybe we can first discuss those before proceeding further.